Good afternoon, everyone. We're going to give Zoom a minute, or not a minute, but a few seconds for people to start trickling in. It's kind of interesting, funny how Zoom works. I'm used to GoToMeeting, where when you start a webinar, everybody comes in immediately. And with Zoom, it seems like people trickle in over the first 30 seconds. So it's kind of like some useless banter that needs to go on as people enter the room. So I think everybody's in that's going to be in. So good afternoon. Happy Thursday. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And every week we run these Creo webinars. This week we're looking at Creo Simulate and Creo Simulate Advanced. And what's really cool about this tool, it's really a tremendous FEA tool. It does, especially Simulate Advanced, does quite a bit for what you need. I can see your screen there.
Yeah.
It does quite a bit of for nonlinear analysis, and we're going to have Zach Carson, PTC Solutions consultant, go through this. Zach's going to do a great job as always. I hope I didn't jinx him.
Yeah, thanks for that.
You're welcome. If you have any questions while we're going through the webinar, please put those in the chat. We'll try to answer them right away, but at least we'll answer them at the end. And this should take about maybe, what, Zach, 20, 25 minutes maybe?
Yeah, probably about that.
Okay, good. We don't want to, drag it out too long. So without further ado, Zach, take it away.
Yeah, thanks. So everyone can already see my screen. We'll go ahead and jump right in. So we're going to be talking about Creo Simulate and Creo Simulate Advanced. So just from speaking to so many companies in the industry, we have a good idea of the challenges that everyone faces around simulation. First and foremost, when it comes to doing analysis in engineering companies, it's typically something that just the experts do. But in reality, that's probably, and most people would probably agree with this, it's just not the best way to go about it if possible. Doing it that way is expensive, it's time consuming, and the reason for this has historically been software limitations. And that in itself can cause a ton of problems. It puts you behind track with data translation issues, poor communication, the time it takes to actually send models off to do the meshing, to do the analysis. And doing analysis like that almost always means that you're just doing it to catch problems. You're not really using the analysis to find optimal designs, like ideally that's like it should be used for. Now, especially if you're doing this analysis at the end. This part is already designed. You're ready to build it, and then, oh wait, we have a problem. That's an expensive way to do things. And unfortunately, it's the way that most people do it. So waiting until the very end to find out if you've got any issues, then go through the redesigning, send it for analysis again. That's an expensive fix, and it could be completely avoided if you'd have incorporated analysis earlier into the design process. So the solution to these challenges and the solution to that sort of pass-fail mindset is Creo Simulate. It's built into Creo Parametric, so there's simulation integration, and it gives you the ability to implement analysis much earlier in the design process. You can understand the quality of your design earlier. By the time you get to a manufacturable product, you've already worked out all the kinks and you have the best possible design. So what is Creo Simulate? Well, standard Creo Simulate is structural and thermal analysis. So you can understand product performance and optimized digital designs. Make sure that you have the best possible design that you can have. And it's part of Creo Parametric. It's not a third-party product. You're not sending it off to anybody. You're not going to a different interface. You simply say, I have this piece, let's turn it on and let's analyze it. So it enables you to get analysis involved much earlier because of that. So rather than analysis just being used at the end, like I said before, basically as that pass-fail, it actually becomes a tool that guides your decision-making and validates your designs. Now with it, you can do things like optimization and feasibility studies to determine if there's a better way to do something. What happens if I make this wall thicker and that wall thinner? Do I get a better product? Not just does it fail, is there a way that I can make this better? This is what we're doing in Creo. We analyze the geometry, make those changes very quickly and easily because it's in the design tool, and then just update the simulation models and rerun the analysis. Everything is being done in Creo. That's such an advantage to have a tool that does that. And again, you're not just getting another answer. You're not just getting, all right, yeah, this will work. You're getting the best model. You're actually figuring out the analysis, optimizing the design to get the best product, not just another one that works. So with this tool, what really are you getting? Well, you get a full suite of analysis tools. So there's tons of options here depending on what you're working with. And this is really what distinguishes between base Creo Simulate and Creo Simulate Advanced. The demo that we'll go through today is pretty much base Simulate. Simulate Advanced just gives you additional capabilities to do other types of analysis. So depending what you're doing, you'll probably want to use Simulate Advanced. Really, the line, it starts basically after steady state thermal analysis. So everything below steady state thermal analysis is going to be where Creo Simulate Advanced comes in. If you're doing nonlinear contacts, if you're doing isotropic and composite materials, dynamic and pre-stress analysis, nonlinear thermal analysis, all of that is Creo Simulate Advanced. So basic things, you'll be fine with Creo Simulate. If you really want to get into the nitty-gritty and do those, to be frank, more complex types of analysis, you'll want to go with Creo Simulate Advanced. And if you have additional questions around that, because we're not going to dive into Creo Simulation Advanced a whole lot today, those are things that Rob and I, after this demo, will be able to get more information on and probably get that over to you. Okay. Now, in terms of capabilities that you're getting with Creo Simulate, the first is all around meshing. When it comes to meshing, a lot of times this is considered a specialty, and there's meshing experts out there who will insist that you have to come to them to do the meshing. I don't know why, maybe it's job security, I'm not sure, but in Creo, we're all about automatic meshing. Just let the system do it. It's a painful process to go through doing the meshing. So Creo optimizes the meshing for you. It refines it in areas that need to be refined in. And then after the fact, if you really want to go in and tweak the mesh for whatever reason, refine it manually, you can go ahead and do that. You can override the automatic mesh entirely and just do it all manual. If you want to pick and choose areas to refine it yourself, you can do that as well. And that's the case with anything that you're meshing. It's a full mesher, whether you're doing solids, whether you're doing shells, beams, springs, masses, whatever the case is, we have an automatic mesher. You can also go through and do it manually. So again, let's do more than just see if this thing's going to break, right? Let's do optimization and feasibility studies to improve designs. Let's take these walls and change them from 1/2 inch to a 1/4 inch and see what happens. Use that feedback to drive your decisions and make the best designs. Let you explore and try some what ifs, to be innovative, to see how your product's going to hold up in certain conditions and scenarios. And those changes you make to the model will easily be pushed over into the analysis. You're doing it on the model itself. So if you make a change, you just update the analysis to reflect those changes. You rerun the thing, you see those new results. And doing it this way is much faster, way, way faster than doing this in the traditional way of sending it off to an expert. They do their thing, you get it back, you make changes, and then you send it off again. It's just, that's so tedious, it's so time consuming, and it's so expensive. And then here, it's very easy to parametrically vary properties. Again, because it's just your CAD model. They're not separate from one another. It's the same model, it's the same system. Make a change on the model, update your analysis, and rerun it. And afterward, when you're looking at the results, we have templates that make it really easy to see everything. You can look at different variables, look at contour plots, like you're seeing here on the right, stress, deformation. You can animate the deformation to see how it's going to bend and flex. Is it doing it in the way that you want it to? Anything that'll help you get the best understanding of the quality and the functionality, we're trying to give you that. We're trying to give you the clarity into seeing that. So the results you get, you can output them as various formatted reports for documentation, send them off to whoever needs them. You can even use what we have called a simulation query. So what this does is it gives you an exact result for anywhere you click on the model. If you're looking at von Mises stress, for example, Click in one spot, 80 megapascals. That's your value. You click somewhere else, 40 megapascals. Anywhere on the model that you want to value, all you have to do is click on it. You can even set up probes. So if there's a specific point that you know is kind of a trouble area that you want to monitor at all times, just stick a probe on it. You can always look at that value and see, as you're making changes, how that value is changing. You know, was the change you just made good or bad? Is it improving that value? Is it making it worse? And the point of all this is it's designed to be really easy to use. It's easy to see the results, different types of plots. It's easy to interact with them, to look at multiple variables at the same time. Like you can see here in the snapshot, we're looking at von Mises stress, displacement, and then principal stress vectors. It's just easy to use, right? You don't have to be an analysis expert in order to use Creo Simulate. That's the whole idea of this. So before we jump into our demonstration here, let's see if we have any questions so far. Do not think that we do.
Nothing yet.
All right, easy enough. Let me go ahead and open Creo Simulate, or Creo. There we go. So for this demonstration of Creo Simulate, we'll be working with this machine press that we have. So this is a design that's held together really with this frame around the outside. You can also see on the top corners, we have some lifting lugs there to put it into place on the shop. So these lugs are something that we've used before, but not in this exact instance. So we need to make sure that they're actually going to work. And that's where Creo Simulate comes in. So it's all going to be done in the same interface. If you go up to the top to applications, you just click on Simulate, and then we can get busy. We can put in our loads, we can put in our constraints, put in our materials. It's all going to be done here. And if you look at the top, what basically we try to do with any tool in Creo, just to make it as easy as possible for the user, is we try to make it so that you're working left to right. Most of the tools, if not all of them that you work with, this will be the case. So if it's something where maybe it's your first time doing analysis, maybe it's just your first time doing analysis in Creo, you've always used something else, you come into here and it's going to guide you through the process. Right, so we'll go ahead and start throwing some forces in this thing. We'll say these edges, for example, need a constraint. That's where we actually want to hold the part into place. Then we want to bring in some forces, put some loads on this part. We'll put the loads on the holes here. That's where the attachments are going to go. We'll select both. That's where it's actually going to be, you know, attached to whatever in our manufacturing floor. You can also put a point load out in space that's going to simulate how the weight's going to be held. And then you can display it on the model. So apply those loads, it shows up here. You can actually see what's happening. Did we set it up in the way that we want? If it is, if you verified it, like in this case we have, two different directions, basically twisting this thing is exactly what we want. So now we can move forward. And we've got our constraints, we've got our loads. Let's go ahead and run this thing. Now, when we go to do this, there's lots of different options here: static, modal, buckling, fatigue. In this case, all we want is just a simple static load. We'll go ahead and bring in the constraint and the load that we just set up, we just laid out prior to this. And there's a couple of ways we can go about this as well. We could do it as a single pass or multi-pass. We can say, what % convergence do we want? Basically, you know, how accurate, what sort of accuracy do you need? And then once we've laid that criteria out, that's all personal preference. We'll go ahead and run it. So this is very simple, so it doesn't take long. This one actually is almost instantaneous here. You can see it running here, run completed. It'll tell you the different values within the analysis. And then we can go ahead and look at the results. So whenever I bring this up, you can see this is basically the template layout for the results. So we get an animation of displacement kind of showing how it's moving, how it's flexing, different ways to plot it out, different things that you can plot, different ways to show, just to give you a full understanding of your part. So in this case, we're looking at the stress level of 1900 PSI. That's not going to work. It's way too high, way too much for this particular steel. So what do we do about it? right? Well, we're doing all of this analysis on the actual design. It's not a copy or anything like that. So making a change to that is really simple. And this is where being able to do everything in one system is such a big advantage. Moving between systems takes time. I mean, just sending it off to different users takes time. There can be data translation issues that every designer has dealt with, and it's horrible. Trying to get things to work, trying to make sure there's no loss of data. And it just takes time to go back and forth. It's lots of lost time that can be avoided. So in our case today, there's different ways that we can go about this change. We could make the plate thicker and stronger, but maybe there's some weight concerns there. So instead of doing that, let's go a different route. Let's say within this, we know where the stress level was the highest. It was right in that fillet area. So what happens if I change the fillet? But instead of me changing it, we're going to let Creo change it for us in so many steps, maybe over a certain range, right? So what happens is we run everything. We tell Creo maybe to graph. We need to look at von Mises stress. So we can look at that over all the iterations it runs. We can determine the best one, maybe see if there's a trend there. And then we run that. The run is completed here. And we'll just look at some other different things. So we have options here, right? We look at this thing and we want to monitor von Mises stress. We want to see the graph. And these are the results you saw it calculate a second ago. But what happens is looking at this graph, our value for that fillet, where bent into the tab that's actually being mounted, we were right at about 0.2. Well, that stress value is almost 20,000 megapascals. It's very, very high. Maybe in our own criteria, our own specifications, we want to get this thing down to around 1100. And from this graph, we know that radius, if we want to get down that low, it's got to be right around 0.4 if we want to get to that stress level. So that gives us options, right? We could just simply change that value to 0.4 and we could rerun the analysis, something simple like that. Or what we can do is have the system tell us exactly what value that radius needs to be to get us to the optimal design. So we're going to let Creo do all the heavy lifting for us here. And we're going to set up a new optimization design study. So in this case, we don't just want to make the part thicker and fatter by changing the radius. So I'm going to tell Creo, minimize the mass of this part. I'm going to specify my limits, what I want that maximum weight to be. Or in our case, we want 1100. So we'll specify that. And I can have basically as many of these different design limits as I want to. We can set a max stress. We can set a max displacement. We don't want it warping either. So we'll bring that in and we'll give that a value as well. Say 0.0015 inches would probably be a good value. And then we can throw a range in there too. And at this point, we could go ahead and run the analysis if we want to. And based on what we laid out, it's going to give us the best criteria or the best radius that minimizes the mass. But there's lots of other things here. So we can bring in other variables as well. What if we went in and said, we're going to let Creo change the height, change the width, change the length, change the thickness, all of these different options. If we were doing it on our own, the traditional way, it's going to take hours, if not days, to set up all of that for every little detail, to change each one of these variables individually over and over again. I mean, doing that way could honestly take even weeks. But the idea here is you don't have to do that. You don't have to take all the time. We can select things, variables, and they're going to be put into the spreadsheet here at the bottom for us, where it's really easy for us to look at the variables we define and put in different values. What do I want my minimum at? What do I want my maximum at? What's the current? What do I want my units to be? Set all the ranges all from this one little spreadsheet. And then what we can do from here is we can tell the system, take everything in this spreadsheet and run the analysis. In this case, it's going to minimize the mass. It's going to use the limits we laid out for stress and displacement and change all of those things that we included in that spreadsheet. So things that would take hours or days for us to do, we're going to let Creo do it here. And you can see it calculating, and it's going to do it in seconds, right? It's trying all the different options. It says, are the limits satisfied? Are we getting towards the limit? Are we moving away? If you were to look through these values, it's actually just going back and forth and just doing iteration after iteration until it finds the optimized shape for the part that we just laid the constraints out for. All right, so now we've run that optimization. We can look at what this thing looks like. So in this case, it's a lot different. The fillets are much bigger. It's bigger on the outside. The tab's a lot smaller. But if you remember, one of the biggest goals that we had there was to cut down on the weight, right? And that's exactly what we did. We could even go in this and we could review everything if we want to, see what Creo actually did to get to that optimized model. So it's not just creating this thing and not telling us what it did. I mean, we want insight into what's happening. If we're letting a system make changes and optimize for us, we want to see the steps it took, right? So it's running through those steps here. You can look at each one of these steps. It's lowering the tab, it's rounding the edge, cutting down the mass, changing the size, shrinking it down, but it's all still meeting our design goals. And it keeps going until it gets us to that optimal part. And again, this isn't just a pass-fail design that we have now. This is the best possible design we can have for this part that meets all of the design criteria and all of the design goals that we just laid out. And all of that is being done in Creo Parametric using Creo Simulate. So that's really what I had planned to go through for the demonstration. I do have a few more points I'd like to share back in the PowerPoint that just summarize really what this tool can do for you. But before that, does anyone have any questions? I don't see any in the chat.
No, I think your presentation explanations are spot on.
Awesome, thank you. We'll go ahead then and jump back in and finish this thing off.
Cool.
Right, so what are you going to get with Creo Simulate, right? One, you're gonna lower product costs. You're discovering design flaws and problems much earlier in the process so that by the time you get to a manufacturable ready product, it's gonna be successful and it's gonna function the way that you'd expect. And you're going to be doing that without ever having to rely on things like physical prototypes, right? It's, to be frank, it's old-fashioned, it's very expensive, it's very time-consuming to build them. And if you have a tool like Creo Simulate, you just don't need to do it. Save the money on it. You'll know the functionality of it. Those physical prototypes can just be avoided. And that's going to reduce your material costs just by eliminating the prototypes, but also by doing what we did today, having Creo figure out the best possible design for us that reduces the amount of materials that we use. You don't have to create a physical prototype for one version, test it out, find out it fails, create a new prototype for the next version, send it off for the analysis, get it back, do it all over again, and repeat the process 10, 15 times until you get to the best result. Creo Simulates, it's helping you avoid all of that, save the time, and save the money. It's also going to lower the lifecycle costs. So you're figuring out design flaws much earlier. And these aren't going to be long, drawn out development and review cycles that take forever. They put manufacturing behind schedule right from the start when you're doing it that way. It just prolongs everything and costs a ton of money, right? So we're decreasing the cost associated with that. And then lastly, you're going to reduce aftermarket service and warranty expense. Let's solve all the problems before they ever get to the shop floor, much less than actually getting out to the customer site, and then you have recalls or you have to send out technicians and engineers to figure out the problems, to address the recalls, to repair the equipment, or maybe replace the equipment if it was something a little bit more severe than just something basic where you can interchange a part. That, I've seen it happening firsthand. I've been involved in, the process when that happens. I've been involved in it personally, and it's time consuming, it's expensive, and it just, with a tool like this, it can just completely be avoided. Right? So again, I just want to finish off kind of showing you here the differences between simulation base and then simulation advanced. So the check marks are really where it starts to distinguish between the two. So basic Creo, you can do static structural analysis and simulate parts and assemblies. You add in the extension, you can bring in buckling, steady state thermal, beams, shells, masses, springs, design optimization, nonlinear contacts. Then when you get into the isotropic materials, composite materials, deformation, nonlinearity, dynamic and pre-stress analysis, that's when you'll have to go down the route of getting Creo Simulate Advanced. Okay, so I hope this provides you with a better understanding of what Creo Simulate is all about, where you can distinguish between Simulate versus Simulate Advanced, and I hope you enjoyed the demonstration.
Zach, I think you did a great job. I'm going to actually share my screen real quick, and hopefully we will be out of here in about 60 seconds. Whenever you're making a decision to purchase or use software, I think one of the questions that need to be answered is, can my team use it, and how quickly will they become proficient at using this tool? And one of the things that we do, and this is at no charge, we give 2 hours of desk side coaching. So if you were to purchase Creo Simulate or Simulate Advanced, we would have our FEA, our resident FEA expert, Bill Stickney, work with your people for 2 hours on a project that you are currently doing to help you understand how to use the software and become proficient quickly, as opposed to sitting in a training class and learning things that you may or may not use. We take a different approach where we want to teach people how to use the software for what you need it to do. So with that, we've helped a lot of our customers. When Zach was just talking about how much time this could save, we have one customer from purchasing a simulation tool from us that's saving 2 weeks of production time, 2 weeks, which is pretty amazing. We've also worked with entities in the military and NASA with using these simulation tools to help them make a better product, to figure out problems with rockets, with the weightlessness pool that they have in their training facility. So we've done some pretty cool stuff, and this is no doubt a great product. And if it's something that you have any questions with, we can also figure out if it makes sense or not. Sometimes it makes sense just to have us run the simulation for you, do the simulation tests for you instead, because we do FEA and CFD services also. So if you have any questions or think of anything, you can just reply to the email invitation that was sent to you. Those any correspondence will come directly to me. You can contact us at info@3hti.com. And I want to thank Zach for being on, for leading us this week. He always does a great job. I appreciate his insight and his professionalism and his expertise. And next week, our webinar is going to focus on the design exploration extension, which is a really cool capability that's in the base license of Creo that a lot of people either don't know about or don't use. And this is something that people should use more often, as far as to create some what if scenarios. What if this part was designed this way as opposed to this way? It has different checkpoints within Creo that you can try different ideas and different designs. It's pretty awesome. So we'll have that next week. You'll be receiving the invitation. So thanks again for being on today, everybody, and enjoy your week. Take care.